So let's talk about the ListIterator in Java. So the ListIterator in Java is the most powerful iterator or cursor that was introduced in Java 2 because it's bidirectional. It's a bidirectional cursor. So the Java ListIterator is an interface. It's an extension of the iterator interface, in fact. So that is used to retrieve the elements from a collection object in both forward and reverse directions. So in simple words, it's an object by which we can iterate the elements of a list in both forward and backwards directions. It adds an additional 6 methods that reflect the bidirectional nature of a list iterator. So by using the list iterator, we can perform different kinds of operations such as read, remove, but we can also do replacement of the current object, which we couldn't do before, and the addition of the new elements. So the Java list iterator can be used for all lists implemented, such as the array list, the linked list, stack, vector, a copy on write array list. So anything that implements list, you can go ahead and use the list iterator on. So we can create a list object by calling the list iterator method. So perfect. Okay, so instead of the iterator method, we'll use a list iterator method. Let's go ahead and the general syntax for creating a list iterator object in Java is to public class. So we would invoke list iterator and it would return back to us a list iterator, just as you'd expect. Okay, so key point, when we use list iterator string, the return type of the next method is going to be a string. So it works very similar to the way the iterator method works. So let's move on. And again, we want to use these type parameters and make sure that they match with whatever your collection is. Okay, since Java list iterator interface extends the iterator interface to add a bidirectional traversal of the list, all the methods provided by iterator are also available by default, right? So we get everything iterator had plus more. So we have a total of 9 methods we could potentially use in list iterator. So for forwards direction, we would have the has next, the next, and the next index. So next index is going to be the method that returns the index of the next element in the list. The return type of this method is an integer. So prior to this, iterator just had has next and next, but because this is a list and list guarantees to have maintain the order of the elements that were inputted into the list, then they have a notion of indexes. So a list iterator should be able to return an index in addition to what the next element is, which might not be true for other data sets or data collection types. So for the backward direction, there is a has previous method. So that's going to check the list that is going to check to see if the list has more elements in the backwards behind the element we're currently at. And if it does, it will return true. Otherwise, it will return false. It has a previous method, which will return the object that is behind where the cursor is currently at. And it has a previous index, which will return the index of the previous element in the list. And again, that's going to be an integer data type that gets returned. And then our other capability methods that we have on our iterator is the ability to remove an element. So that works similar to the way that it works on iterator. And then we have the ability to set. Now that's a new method that is available to us. This method replaces the last element returned by next or previous with the new element that gets passed into it. And then we also have an add method where we can use that to insert a new element into our list at wherever the location of the cursor is. And again, the difference between set and add is set will overwrite whatever element is in that index, where add will add the element where the cursor is currently at, but it won't delete the thing that's there. It'll just push it back in the list. So here we'll implement some methods to go ahead and see with some sample programs. Let's go ahead and get these. Let's test this one out. So this is going to be our ListIterator test. So let's go into here. Let's create a new class, a new Java class. Yeah. And we can call this ListIterator test 1. Perfect. And then here, let's paste our code. And let me add a 1 there. Perfect. And let's just do some basic cleanup here. Let's get our comments where they should be. Okay, perfect. And okay, that all looks good. Okay, so just running through this code, we're going to import the array list. We're going to import the list interface, and we're going to import the list iterator. So inside of our class, ListIterator test 1, we're going to have a main method. Inside of our main method, we're going to go ahead and create a new array list. And when we go to create this new array list, we're going to go ahead and store it as the most abstract thing it can be, which is going to be a list. This is really common approach in Java programming, to use the most abstract data member if possible. We'll add some elements into our list, a B, and a C. We'll print our list out to make sure we have those elements in there. Then what we'll do is we're going to go to our list, and we're going to invoke the ListIterator method. This will return a ListIterator instance for us. And again, we want to use the type parameters to define what type of element the ListIterator returns. And it's got to be the same type that is associated with the list itself. So if this is a list for strings, this ListIterator is going to be for strings. Then we're going to do a system.out.print with a quick message, just ListIterator in the forward direction. And then we're going to get the value of has next, which is going to be whether there's elements are present or not. And we're going to return the value, we're going to print the value of the elements present. Then we're going to go ahead and get the next index from our iterator. We'll go ahead and save that into index A. Then we're going to advance our iterator. So iterator.next, and we're going to grab the element that the iterator is returning. And then we're going to print out that index A is whatever the string that we get back from our iterator, and that the, that the index of A is whatever the index, the next index is, and that the element value is from the next method call. Then we're going to do the same thing for index B. We're going to now go to, again, ask the iterator to give us the next index, and then we're going to tell it to give us the next element, and then we're going to print out the index and the element. And then we'll do the same thing for C. We'll say, hey, give us the next index for the next thing in the collection, and give us the next value, the next element, and let's print that out. And then finally, we're going to go ahead and we're going to query, hey, is there an element that's present, right? It has next. Do we have anything else? And then we're going to print that out. And then we'll go ahead and attempt to do this next if there's nothing there. And we should get an exception that gets thrown, a no such element exception. So let's go ahead and test this out. Let's run this code and see what our output is. And here we go. So yeah, our list starts at A, B, and C. And then our list iterator in the forward direction. True, we have another element. We're going to grab index 0 with element A, index 1 with element B, index 2 with element C. We're going to ask, hey, is there another element in the array? It's false. We're going to try anyway, and that's going to give us an exception. It's going to alert us to let us know, hey, there's no such element there. Excellent. So how does the Java list iterator work internally? Well, since the list iterator in Java works for iteration in both forward as well as backwards direction, it's called a bidirectional iterator. So for this, let's take an example program to understand the internal workings of the Java list iterator going backwards. So let's grab our source code and then we'll walk through it. Here, let's go here. Let's create a new class. Here, I'm going to call this list iterator test2. Okay, let's do some cleanup here. List iterator test2. And okay, perfect. So we're going to go ahead and use a different type of list here. Instead of array list, we're going to use a linked list. We haven't talked too much about linked lists. We'll do that in a future lecture, but I just want to illustrate that one of the powerful things about using the abstraction of the list data type is it doesn't matter what the concrete version of list is, we can still use all the same data types and calls. Our code is going to look almost exactly the same, even though it's using an entirely different underlying list. So here we're going to import from Java util linked list. We're going to import the list interface so that we can use that as the data type. We're going to store as a variable, and we're going to use the list iterator to be able to walk across our collection. Here we'll create public class list iterator test2. Here we'll make a main method. Here we're going to create a new linked list and for strings, right? We're going to instantiate and save into the list variable. We're going to add to our list or into our collection a B, and C string. We're going to then get from our list the list iterator. So we're going to invoke that list iterator method, and we're going to save that list iterator method into a variable. We're going to print out just a quick message, forward direction iteration. And so while the list iterator has next, we will print out what's next. Okay. And eventually that'll get to the cursor will get to the very end of the collection, and then it's going to stop. It'll end out that while loop. So then what we'll do is we'll print in the backward direction of iteration, and then we'll do the reverse effectively. We'll do a while loop that on our list iterator, and while it has a previous, we'll go ahead and print out what the state of .previous is on our list iterator. So let's go ahead and run this and see what this does. Let's run that. And we should get, yep. So from the forward direction, we get A, and then we get B, and then we get C. And then from the backward direction, we get C, and then we get B, and then we get A. So this allows us, you can see, we can step through our collection both forward and backward. So in this section, if you want to just see as a diagram how the backward direction is working internally and how it's kind of working in forward direction, we can kind of think of it this way. So we've already seen this diagram where if given a list, our list iterator starts at the beginning of the cursor, and then we can invoke has next or next, and then it would advance it to the next element, and we can keep invoking next to advance. Well, in the backward direction, as long as there's something behind us, so we will always want to check to see if it has a previous, but if it does have a previous, we can call previous, and then it just steps back to the prior element. And it can do that all the way until it gets to the head of the collection. So typically, when we're talking about collections, which is like a sequence of objects, we talk about it in reference to a head and a tail. And the head is where the first element is located at the beginning of the collection starts, and the tail is the end. Now, we pretty much just step through that. Okay, so after observing the above figure, we can see that the has previous and previous methods do the same task but in the opposite direction of the has next and next methods. Thus, we can say that the Java list iterator iterates elements of both of the list in both forward and backwards direction. So let's take another look at an example program that will get the index of both the next and previous element from the current position using the next index and the previous index methods. So let's grab our source code here. And let's go here to ListIterator test 3. So let's go to create a new class. Here I'll call this list. Oops. Iterator test 3. Yeah, let's make that. Let's get our source code from the slide. Let's correct this. Okay. And here, let's do a little bit of cleanup. Let's get that comment where it belongs. Let's get this where it belongs. Let's get this comment where it belongs. Let's get this curly brace where I want it. Okay, perfect. Okay. So a quick look at this source code. We're going to import our array list. We're going to import our list interface because that's the variable type we want to save it to. And we're going to import our list iterator. And then here we're going to create a class. Our class is going to have a main method. Our main method is going to create a new array list to be able to hold strings. So again, the type parameter we're going to use there is going to be of data type string. Then we're going to add a lot of stuff into our list. So some colors, red, green, yellow, orange, blue, and white. And then we'll just go ahead and print out the state of our string. Then we're going to go ahead and from our list, we're going to get a list iterator, and we're going to save that iterator into a variable so we can access it and use it to walk across our collection. We're going to create a new line then we'll create a message that just says list iterator in the forward direction. And then what we'll do is while iterator has a next element, we will get the next index. And then we're going to get the next element to advance the cursor. And then we're going to print out the index along with the element. And then we're going to create an empty, just a new line character. And then we're going to create a message. So we'll print out a message that says list iterator in the backwards direction. And then we'll go ahead and use a while loop to continuously iterate so long as our iterator has a previous element, so an element behind it. We will go ahead and grab the previous index and the previous element, and we'll go ahead and print that out. So it should be very obvious what the results of this should be, but let's go ahead and run that. And we can see here, let's take a look, expand this out some. So here's the original state of our list, red, green, yellow, orange, blue, and white. And here, the list iterator in the forward directions. Again, you could see that we step through from index 0 to 1 to 2 to 3 to 4 to 5, pulling each of those elements in the order that they were inputted into. And then for our list iterator in the backwards direction, we have our index 5, 4, 3, 2, 1, 0. So we can walk backwards, grabbing each index behind us the entire time. And again, grabbing the element in from the tail to the head in reverse order. So I have a question. So we don't have to use the before each for testing, for example, putting it before the list. Well, so that's a great question. You don't always, so first of all, I'm not doing JUnit tests in these instances. I'm building just really dirty main methods to illustrate what's happening with the collections framework. So we're actually serving as client developers towards the collections framework, and we're using it to build applications, albeit the applications are very simple, just to kind of show you what the behaviors are. So, but in terms of JUnit and using the app before each, it's not mandatory to use it. I mean, you could set up all of your data inside of each of your test methods, but if you don't want to set up all of your data in each of the test methods, it's easier and it's more compliant to the drive principle to have before each method that sets up all the data that you intend to test with. Does that answer your question? And so here, just some key points about what we just saw in that last example is that if we use the next method followed by the previous method, the list iterator goes back to the same position. So the call to the next method moves us one index forward, and the call to the previous method moves us one index backward. So keep in mind that is a thing about a bidirectional cursor. Okay, so how do we add or set elements into the list while using the list iterator? Because we said that was one of the new things, one of the powerful things about a list iterator over an iterator. So let's create an example program where we can add an element to the list before the iterator position when the Java list iterator is iterating the list in the forward directions. And then what we'll do is we'll replace the last element returned by the previous method with a specified element during the backward direction. So we're going to do a little bit of setting both while moving forwards and backwards. So let's grab our code here. And I'm going to go here into our source. Let's create a new Java class here. We'll call this list iterator test 4. And yeah, so I've been calling this task. I see we've been calling this task, but I've been cheating. I've just been making the main methods. So the old school way of testing to show you how to use this in practice. Okay, let's paste our code in here. Let's call this list iterator test 4. Okay, so let's do a little bit of cleanup before we walk through it. Let me get my curly braces where I want them. Let me get my comments where I want them. I am very particular about the format of code for readability's sake. Okay, perfect. I think that looks great. Okay, so we're going to import ArrayList as our concrete class that we're actually going to instantiate. We're going to import our list because that's going to be the data type of the variable that we're going to use to store our list. We're going to import our list iterator because we want to be able to use that to walk across our list, our collection. Here, we're going to create a new class so that we can actually build a simple application. We're going to implement a main method so that we can actually execute our application. Here, we're going to create a new array list, and we're going to save it into a list data type. And we're going to use the type parameters such that our list is going to hold strings. Here, we're going to add some strings, 4 of them, A, B, C, D, and then we're going to print out the state of our list. We'll create a new line character so that our output is pretty. We will then, from the list, we will get the list iterator object, a list iterator object, an instance of list iterator, and we will save that into a variable. So one thing about this is you can keep invoking list and get different list iterators, and each list iterator will track its position. So it's possible to manage 2 or 3 or 4 different iterators at once. And that's one of the really powerful concepts about having an iterator object that maybe I hadn't discussed before, is that we can keep asking for more, and then we can use them in different and interesting and novel ways and how we advance them, or I guess go backwards as well. Okay, here we're going to print out a message, the forward direction iteration, and then while our list iterator has a next, we will print out the next element and display that. And then what we'll do is we're going to add an E. So notice on list iterator, we're going to invoke that add method. And this is going to add an element before the iterator position. Okay. Then we're going to go ahead and create a new line and then print out the new state of our list. Then we'll create a new line. We'll print a new line here. And then we're going to print out a message, backward direction iteration. And then we'll do a while loop such that as long as our list iterator has a prior element, we're going to print it out. And then once we get to the end of that, we're going to set. So we're going to replace the element that we're currently at with the value of J. So this will update the last element returned by previous. And then we'll print out a new line, and then we'll print out the new state of our list. Excellent. So let's print this out. Let's actually run this code and let's see what the output is. So here, the initial state of our list is A, B, C, and D. And then for a forward direction iteration, right, we're going to go and keep calling that next, which is going to give us A, B, C, D, and then we run out of values. So we stop that while loop. Now we're going to add the E. And so add is not going to override anything. It's actually going to add a new element into our list. So now notice the last element is E. So now for backwards direction, now since add had added a new element, that is now going to be part of our walk. So for our backward direction, we'll start with E, then D, then C, then B, then A. And then we're going to set where the cursor is currently at with the iterator. So we're going to place the A with the J. Okay, so let's take an example program where we will remove an element returned by the last call to the next method. So let's make another sample program where we go ahead and do something just slightly different, but relatively the same. So that way you can kind of see all the different behaviors of how these iterators work. So let me go here and create a new Java class. I'll call this ListIterator test 5, and then I will make all these available inside the Git repo. ListIterator test 5. Okay, let's do some basic cleanup work here. I want my, okay, everything else looks good here. Okay, so here, I'm going to import my array list because that's going to be my concrete class that I'm going to actually instantiate. I'm going to import list because that's the data type of the variable I want to store my array list in. I'm going to import list iterator because that's how we're going to walk across our array. I'm going to create a class of list iterator test 5, and I'm going to create a main method so I can actually execute this Java application. Inside our main method, we're going to create a list. It's going to be specifically an array list, and it's going to hold strings. We're going to add 4 strings into there, A, B, C, and D. We're going to print out the current state of our list after that. Then we're going to get a list iterator from our list, and we're going to save that into a variable. And then we're going to print out a message, forward direction iteration. Then so long as we have a next element, we're going to print that element out. And then we're actually going to invoke that remove method. Similar to what we had done with iterator, right? But just to illustrate that we can do that we can remove using a list iterator as well as the iterator instance. And then we will print out the new state of the list. Okay, so let's go here and run this code. And here we can see that our list is A, B, C, D. We're going to walk through it, A, B, C, D. And now we're going to tell to remove the current position of our iterator is at the last element. So when we call remove, it's going to remove the D. So the new version of our list, the new state of our list is A, B, C. Excellent. Okay, let's move on to another example of using list iterator. So one more important example program is what happens if we do not use the generic type. In this case, we will need to do typecasting. So we'll also perform remove and add operations in the program but you'll see why it's important to use, here the idea is that you see why it's important to use the type parameters. Let's see if I can't grab all this. Perfect. Copy this over. And let's here create, this is, yeah, 6. Let's create a new class. This is going to be list iterator test 6. There we go. Okay, let's do some basic cleanup work there and there. And let's indent that here. And let's get that curly brace there, and that curly brace there, and this curly brace here, this curly brace there. Perfect. Just reduces the vertical space, which is good when I'm trying to share a screen. Okay, here we go. So I'm going to import what I have been importing, right? Well, actually, I'm not going to import the list. In this instance, I'm going to use array list, and I'm going to import the ListIterator interface, and we'll just go ahead and use the array list. So here in our main method, we'll create a variable of data type array list. And we're doing that because we are using the non-type parameter instantiation, right? So we're going to call array list without telling it what type of values it holds. So when we do that, it implicitly is going to treat everything as just an object, which is the mother of all data types and has the least amount of privileges to what the internal set of methods you have available are. So you'd only have access to the methods that object declares it has. Anyway, so we're going to go ahead and we're going to add in apple, orange, banana, guava, pineapple, and we're going to print out the state of our list. And then we're going to create a list iterator, right? And notice we're not using the type parameter here either because we didn't use the type parameter here. So the default is going to be it just returns an object. And so while the iterator has a next, then we will get the next object. So it's going to be of data type object. But if I actually want to do things with the values that I'm withdrawing from it, I then have to manually cast. I have to do this type casting to convert the object data type so it can be treated as a string data type, and then I can store that into a string data type. And then I can then start treating it like it is a string. Now it's a string. str is a string where o is an object in terms of the variables privileges to the membership of where it looks for what methods and fields it has access to. So then we can do this check, this equality check. If string equals orange, then we can tell, hey, iterator, remove it from our collection and then print out the new state. Else if it equals guava, we're going to add grapes to our list and we'll go ahead and print out the state of that. Otherwise, if it's pineapple, we will override pineapple with pears. So again, this is just basic processing like we've already seen, but I just want to show the value of what generics provides to us. Otherwise, we have to manually typecast for everything. And effectively, this is what's kind of happening behind the scenes for us. Okay, and see here, we can then run that like normal, without any kind of generics involved, but you can see there's a lot more overhead for us to go ahead and manage things. So here we have apple, orange, banana, guava, pineapple. And then we have apple, banana, guava, and pineapple because we've done the removal. And then we're going to do apple, banana, guava, grapes, pineapple. We're going to do the addition we're going to add. And then finally, apple, banana, guava, grapes, pears. That's the set, where we set from pineapple to pears. So it's going to remove whatever element it's pointing at inside of the iterator. So remember, one of the first programs we looked at, so I have a question. Does it remove the last element because it was the last one printed out? Yes, it's going to remove whatever is the element it's currently pointing at. So recall in one of the earlier examples, we used an iterator to remove all the odd numbered values in a collection that had integers from 0 to 8. And so we were able to remove each one as we evaluated it. So if that value was 1, then we're like, okay, iterator, remove the value you're currently pointing at. And then that new value became 2, or at that place. Then the 1 disappeared, and then it just became a sequence of 0, then 2, and then the rest of that sequence. And as we walk through the array, removing elements, we're able to change or mutate the collection, not the array, but the collection, such that it only held even values. Does that answer your question? Okay, so some advantages of the list iterator in Java is that the list iterator has several advantages. The list iterator in Java supports many operations such as read, remove, replacement, and the addition of new objects. And using the list iterator, we can perform iteration in both forward and backward directions. And then the methods of list iterator are easy and simple to use. And some limitations of the list iterator. The list iterator is the most powerful cursor, but still has some limitations. The Java list iterator is applicable only for list implemented class objects, right? So if it's not implementing the list interface, you can't use it. And therefore, it's not a universal Java cursor. That's the role of iterator, but iterator has less calls. But you have to know less about your data collection, what type of collection type you're using to be able to use iterator versus list iterator. And it's not applicable to the whole collection API because of that. So similarities between iterator and list iterator. Both were introduced in Java 2. Both are iterators that are used to iterate elements of a collection object. Both support read and delete operations. Both support forward direction iteration, and both are not legacy interfaces, which we don't care about. Or so far past Java 2, we're in Java 17. So the only legacy interface you'd have to worry about is vector, and that's deprecated. So don't ever use the vector class. In which case, then you have to use an enumeration as your iterator. So that's outside the scope of this class. Okay, so the difference between the iterator and the list iterator. So for iterator, the Java iterator is applicable to the whole collection, whereas the list iterator is only applicable to list implemented classes, such as array list or linked list or stack. It's a universal iterator, whereas list iterator is not a universal iterator. For iterator, iterator supports only forward direction, whereas list iterator supports both forward and backward. Iterator is known as a unidirectional iterator because of rule 3. List iterator is known as a bidirectional iterator because of rule 3 on this table. For iterator, it supports only read and delete operations, whereas list iterator supports read, remove, replacement, and addition of new elements. And we can get the iterator object by calling iterator method, whereas we can get the list iterator object by calling the list iterator method. So a quick kind of breakdown, a cheat sheet for you. Okay, that is all I have to really show for the list iterator.